Being able to measure, interpret data, and having an understanding of knowledge is an important thing for students to know. To most students, math is pretty boring or a hard class, um, and that can be confusing and frustrating. Most students usually feel this way because to them, math is just a bunch of numbers and then worse, word problems that have no use in their lives. As teachers, we want to challenge this. Um, Take the fifth grade standards of measurement and data, specifically the standards 1 and 3, for example. These standards go over how to convert like measurement units, such as centimeters to millimeters, and the understanding of geometric measurement, specifically volume. And they want you to understand concepts of volume, understand one cube one cube unit, measure volume in cubic centimeters, millimeters, whatever it may be, and relate volume to the real world. So teaching that is something that can be as overwhelming as it can be to learn it, or at least in the beginning, because I think the hardest thing for students is, like I said, numbers are scary and math is not useful to most people, or so they think, when in reality you actually use math on a pretty daily basis. I think the important mathematical concepts for students to know is always the real world applications. I think the biggest thing is relaying to students how it fits into your lives, and not just down the road. We can always say, well, one day, when they're adding and subtraction, well, one day you have to balance your checkbook. So you need to know how to add and subtract with decimals because you have to do this. Well, that's one day, and to them, doing that when they're in their 20s or 30s is not something that they can grasp now. So we have to do things that are more on their level, where addition and subtraction is, well, you want to know how many M&Ms you have, or things like that. So I think for fifth graders, you can't tell them, well, one day you might need to know how to do this. 30 years from now, you have to really sit with them and find what works for them. So I know Wyoming is huge with 4-H and things, and boys, things like that. So I feel like try and relate it to that. Try to relate your measurements to that. If they're doing word working, well, try to relate, if you have 10 centimeters of a piece of wood here, how many millimeters do you have? If you have a meter of this, and you need this many centimeters, how do you figure that out? I think you really need to look at your students' lives specifically, and as your class changes each year, maybe your teaching methods have to change each year because students are different and they're into different things. And one year you may have a lot of kids that are into 4-H, but then one year you might have a lot of football players or sports kids, and you need to figure out how to relate units of measurement to them, or how to relate volume to them, because they don't care. If it doesn't relate to them, they don't care. And I mean, I can say that personally. When I was a student, if I didn't know how it was going to affect me later, I didn't care to learn it. And I know my 7-year-old son feels the same way. So I think that's the biggest thing, is really trying to focus on how to do that. So I think concepts that you want the students to understand. I think the biggest concepts you want them to understand with the first one of measurement and data is to convert measurement units. You obviously need them to understand the basis of what a measurement unit is, and that it's simple to convert them. It's just multiplication or division, and you really want to show them that it's easy things to do. And with the volume, it's kind of the same thing. I think But more than math, I don't know. This one's hard because I feel like more than mathematical concepts, like they do need to understand how to do the math of it. They do need to understand why 1 cubic centimeter is 1 cubic centimeter, and that um, 1 cubic meter is, you can put it into a cylinder, but it's not technically a square. Like, there's all sorts of things that they need to understand, but I think the biggest is to get them on board with wanting to learn it, because then you can teach them anything. I think the biggest misconceptions that students have is how many centimeters are in a millimeter, or how many centimeters are in a meter, or that conversion process can kind of be confusing. Where, well, do I multiply to find centimeters and meter? Do I multiply it by 100? Do I multiply it by 1,000? Do I multiply 10? I think so. Those are kind of the hard ones, and trying to visualize what they really mean. So I think having models for students is a huge thing to do when you're doing that, so they can really see, oh, there's 100 of these lined up, and that makes a meter, or there's 10 of these, and that makes whatever the case may be. I think the biggest misconception for volume is when you want students to double volume. I think that they're going to say, oh, well, this one's 2 cubic centimeters, and so we're going to make it, now the length is 2 centimeters, and so now we're going to make the length 4 centimeters, instead of it being, that they don't understand that triples. And so I think that you really have to get them to understand that there's 3 things to volume, that you have length, width, and height, and they don't understand that makes it triple the volume rather than just double the volume, even though you double the side. I also think, I just discovered a big misconception that tall and skinny is not the same as something that's short and fat. If it's twice the height, it doesn't matter. It's still, there's less volume. And I think that showing them and explaining them those things will also make them want to learn more about geometry, where you can say, oh, well, look, you can have more this way if your glass looks like this, or you can have more this way if your container of popcorn looks like this, or whatever. So they can really do that, and even if you have to say, well, if you know this and your little brother doesn't know, then you get more, and he thinks he gets the same, and even though he doesn't. And I think with teaching volume, that using little cubes to show them how things fit in there, or specifically taking different glass sizes or container sizes and showing them physically what fits in there would really help. That they need that visualization. And ideas for encouraging students to think mathematically. I think the biggest is why. Why does this work? What makes it work? And explaining that to them, why it works, and why it's important that they know that it works. Why it's important for them to understand that doubling the length of a cube triples its volume. Well, why does that work? Because you have 3 different things. And I think that you really need to encourage students and show them why things work. And I think that you need to help them understand that understanding why actually makes math a little bit easier for them. But again, just to think for them to think mathematically, I think that the biggest thing with math is you have to show them it's not scary. It's just numbers, and numbers are always going to work the same way. There's no, in English, it's I before E except after C, and all these other words that don't work with it. That it doesn't matter what you do, because 2 plus 2 is 2, and 2 times 8 is 16, and that doesn't change. There's just different ways of showing why it is the way it is, and that they really need to understand that the math is not going to change on them, and the math's not going to fail them. They just have to put in the time and effort to understand it. And the more, I think, as a teacher, that you can make math real, then the more your students want to know, and the more fun you can make math, the more they will want to know.